Compound interest. Definition. If P dollars are deposited in an account paying an annual rate of interest R, compounded, paid in times per year, then after 2 years, the account will contain A dollars according to the following formula. So we have the formula here, where A is the future amount, where P is the principal amount or initial amount. R here is the rate in terms of percent, and N is the compounding period. So that's the N times per year. We have N also here to the power, and T here is the number of years. Let's have an example. Suppose $1,000 is deposited in an account paying 4% interest per year, compounded quarterly. So compounded quarterly means you have 4 for your N here. So the R here would be 4%, and your P here is your 1,000. So that's our P. Okay, applying the formula. So here's the question asked: find the amount in account after 10 years. So 10 years would be our time with no withdrawals. So our formula is A equals P times 1 plus R over N to the power of Gn. Okay, and we're looking for A here. So our P here is 1,000 times 1 plus our R should be converted, the 4% should be converted into decimal. So just move the decimal point from right to left 2 decimal places and you will get 0.04. Or you can divide 4 by 100 because the percent symbol means 100. So 4 divided by 100 would be 0.04. So it's just the same thing. Divided by our N, which is quarterly. So when you see quarterly, you have 4. You have monthly, you have N is equal to 12. Daily, your N would be 365. If you say yearly, your N is equal to 1. Semi-annually, that would be N is equal to 2. So those are the terms that we have to note, so we will know what would be our N. So in this case, quarterly means 4. So we have to have 4 here at the bottom. Then raised to the power of our time is 10. So 10 times our N, which is 4. Okay, so now we can enter this exactly in our calculator. And our answer would be in dollars. That would be 1,488.86 cents. So that's the future amount after 10 years. So that would be our answer. Okay. So using your TI 83 or 84, you can actually plug that in exactly as the formula. You don't have to do it one at a time. So 1,000 first, then parenthesis 1 plus you have 0.04 there. So you can put a parenthesis there because that's two numbers involved. 0.04 divided by 4, then close parentheses, and then another parenthesis, and then to the power, that's 10 times 4, that's 40, to the power of 40, and then hit enter. So the answer would be 1,488 and 86 cents. Okay, so next problem. So the next problem, how much interest is earned over the 10-year period? So since you have 1,000 as your principal here, you just subtract what we got a while ago in letter A. So our answer would be 1,488.86 cents minus the principal or the initial amount deposited, which is 1,000. So we will get 488 and 86 cents. This is the interest earned over the 10-year period. Okay, so just try to memorize the formula so you can apply the formula. So find the given information and look for the missing one. And next, we need to know the continuous compounding formula. So that would be right there. Continuous compounding formula. It's a little bit similar to the compound interest formula, but in this case, you have the word continuous compounding, or you can have the word continuously in your word problem as a given information. If P dollars are deposited at a rate of interest R compounded continuously for T years, the compound amount A in dollars on deposit is given by the following formula. So we replace the group of 1 plus R over N with E here. And our E here, it's an arbitrary variable that you can find it from the calculator. And the value would be 2.718. So you can find that one. So it's an irrational number. So that would be the rounded value. So the estimated value, like your pi. But just press that E in your calculator. So you can actually get the exact value. So here's the formula here. Future amount is our A, principal still the P, and our R is the rate, and then T is our time, number of years. Okay, so I'll give you a chance to read the problem here. Suppose $5,000 is deposited in an account paying 3% interest compounded continuously for 5 years. Find the total amount on deposit at the end of 5 years. Okay, so let's get all those informations. So our P here, the initial amount deposited or principal, it's 5,000. So that would be our P. And then our time, that would be 5 years. And then the R, it's 3%. That's our R. And we know what is E. So E can be taken from the calculator. And E has a value that's 2.718 approximately, right? But you can always use the value from the calculator. So you will have an exact answer. So here's the formula for compounding continuously. So that would be A is equal to P E raised to the power or to the power RT. Okay, and our principal is 5,000. Dollars, and we have E here. Our R is 3%. We have to change 3% into a decimal value. So that's moving from right to left, the decimal point, and you will have 0.03, or you can divide 3 divided by 100. So that would be 0.03 times time, which is 5 years, 5 there. Okay, and just applying the formula and use your calculator to evaluate the expression. So you type 5,000 first, and then E is the second function of your natural log, ln. So press the second function in your calculator and then hit ln, and you will have that 0.03 as a power times 5. Okay, and don't forget to close this with parentheses. So it will be evaluated as a power. And then hit enter. So our answer now would be in dollars. That would be 5,809 and 17 cents. Again, the answer would be 5,809 and 17 cents. So just don't forget to write the unit. It should be the dollar sign. So that would be the amount or the future amount after 5 years with the initial deposit of $5,000. So those are the two formulas that we have to memorize: the compounded interest formula and this one, the continuous compounding formula.